Okay. So, good evening, students.
Good evening, sir.
Good evening. Good evening. So, I think we have finished almost all the quantum mechanics, but some topic is there. आपका just exam का announcement होने दो. I will just cover this topic. But I think you have to just revise all this thing. Revise कर रहे हो या नहीं कर रहे हो? This is very important, है ना? और test देते जाओ.
Yes, sir.
Okay,
Yes, sir.
great. So, listen, what I feel that people who are learning atomic physics, वो मेनली चीजों को याद करने की कोशिश करने लगता है. ठीक है, ऑब्वियसली कुछ चीजें याद करनी होगी बिकॉज एक्सप्रेशन आज वेरी लेंदी एंड उसे एग्जाम में डिराइव करना बहुत ही मुश्किल होता है. बट इन स्पाइट ऑफ दैट, व्हाट वी हैव टू डू, वी हैव टू एटलीस्ट सी दैट फ्रॉम वेयर दिस एक्सप्रेशन विल कम इनटू पिक्चर. आर यू गेटिंग माय पॉइंट? ये हमें थोड़ा समझना पड़ेगा कि ये सारे एक्सप्रेशन कहां से आ रहे हैं. So I have especially make this particular chapter, that basic of quantum mechanics for atomic physics. Mainly I will start today from the semi-classical theory. So what I am going to discuss in this particular 3 and 4 session, and parallelly Mukadder sir will take this atomic part, जो आपके mainly जो एग्जाम में रिलेटेड है एंड जो ट्रेडिशनल एटॉमिक पार्ट है. बट आई एम जस्ट गोइंग टू कन्फाइन माई सेल्फ विद अ सिंगल पार्टिकल सिस्टम, हाइड्रोजन एटम. और हाइड्रोजन एटम के प्रॉब्लम को ही आप आगे ले जाकर के 2 पार्टिकल एंड 3 पार्टिकल सिस्टम में ले जाकर के उसके लिए कैलकुलेशन करते हो. ठीक है. सो व्हाट आई एम गोइंग टू डिस्कस विथ यू टुडे, आई विल जस्ट गो एंड डिस्कस विथ सेमी क्लासिकल थ्योरी ऑफ बोर एंड समरफील्ड. So we have to start from here, and then we will try to learn what is fine structure and what is significant of fine structure, and from where this fine structure will come into picture. Obviously, we will introduce the perturbation to the hydrogen atom, and once we will introduce the perturbation, the first perturbation is relativistic correction, and second is LS coupling. So these two will mix together, and this will give you another story of hydrogen atom, that is a story of fine structure. So this is the story of hydrogen atom without any field, and obviously whatever the field, that is internal field. And next we will also try to learn within a G-man effect, when we will put hydrogen atom in some magnetic field, and we will see the further splitting of the state with the, if we are putting the hydrogen atom into some magnetic field. So we have done all this thing into quantum mechanics, don't worry, but we will recap all the thing such that you can learn atomic physics in a very coherent and in a very scientific manner. Okay, atomic physics is not that just putting the line and seeing the transition. Atomic physics is all about why this line is coming and what is mathematics behind this line is very important. Okay, so let's try to go for a first Bohr-Sommerfeld theory, and first we will go for Bohr theory. So there are n number of ways to discuss this Bohr theory, but I will use purely classical theory, जो हम लोगों ने central force problem में पढ़ा है. So once you have learned this thing into central force problem, then obviously we have to apply whenever the classical theory will come into picture. So let's go for Bohr theory. So what is Bohr theory? It's a very interesting one. So this is your Bohr theory. Bohr theory will tell you all about the circular path or circular orbit of hydrogen atom. It has just tell you that there is electron and there is proton, and this nucleus of hydrogen atom is single particle, that is proton, and electron and proton have only one interaction, and that interaction is equal to Vr is equal to minus K by R, where K we can have, this is electrostatic potential, so K is equal to E into E by 4 pi epsilon naught, isn't it? And negative sign will tell you that this is all about attraction, because this has positive charge and this has negative charge, so these have all about attraction. Okay, and obviously we know that angular momentum of system is conserved because this is nothing but central force potential. Yes, ये तो हम पढ़े हुए हैं. So this is your conserve. So J is constant. J is constant. Now, what Bohr argue, okay, J is constant, but it is quantized. And obviously this motion is confined into plane. Yes, because we are just working for the central force problem. And in a central force problem, we have discussed all these things that motion is confined into a plane. So if this motion is confined into plane, then obviously what is my V effective? What is my V effective? My V effective is equal to J square upon 2mr square minus K, and I can write this value is equal to E square upon 4 pi epsilon naught R. So this is our V effective. And obviously, if we are just going to plot this particular V effective, then we remember this is my V effective. V effective versus R, isn't it? And for this particular value, there is an orbit, and that orbit is what? Circular in nature. You remember this value? This value is nothing but what? E naught. याद है आपको? ये सारा हम लोगों ने सेंट्रल फोर्स में किया था. So you have unique circular orbit, and this value is given by E naught, and E naught की value negative में आया था. Can you remember what is the value of E naught? क्या आया था? Minus ये बताओ क्या आया था? Otherwise I will derive it, don't worry. क्या आया था पुनीत? What is value of circular orbit energy?
Minus E square upon 8 pi epsilon naught R.
E square upon 8 pi epsilon naught R.
Yes,
So minus m
negative
k
of
square
kinetic
upon
energy.
2j square.
J के टर्म में बताओ क्या आया था? बताओ E naught.
Minus m k square upon 2j square.
Very good. E
Yes,
naught
sir.
is equal to minus mk square upon 2j square. ये हम कहां से निकाल पाए थे? बहुत ही डिफरेंट तरीके से हमने निकाला था. एक या दो तरीके से नहीं, कई तरीके से निकाला था, है ना? बट एक्चुअल ऑर्बिट इज, if this is your potential, classically you have different type of orbit if you are going to change this particular energy level. But Bohr strictly says that particle will always maintain the circular orbit with quantized J. And what will be that quantized J? And he just say that P theta d theta is equal to NH. And you can just put N theta H or NH. You can just put NH from here. And obviously, you have to just go for a complete periodicity. And what is this P theta? This P theta is nothing but this J, isn't it? And this J is constant, so you can take this thing outside and you have 0 to 2 pi is equal to NH, and you have J, and that value is equal to NH cut. Okay? So Bohr argued that particle will always go into circular orbit, और पार्टिकल हमेशा कहां जाएगा? सर्कुलर ऑर्बिट में रहेगा, जिसकी एंगुलर मोमेंटम क्वांटाइज्ड है. So if angular momentum is quantized, then obviously your energy will also quantized, because your energy is nothing for the circular orbit is equal to what? V effective. Yes?
Yes,
For
sir.
circular orbit, your energy is nothing but V effective. Don't worry, we can find this thing in n number of ways. Now you can put it here. This is your, so what is your radius? Radius क्या होगा? Del V effective upon del R is equal to 0. At some point R is equal to what? R naught. ये होगा ना? Yes. And this
Yep.
value is equal to nothing but J square upon mr cube is equal to E square upon 4 pi epsilon naught R square. This is nothing but the centrifugal force is equal to external force. Don't worry. This is centrifugal force is equal to external force, and this is condition of circular orbit. So from here, you can easily find the value of R naught. And what is value of R naught? The value of R naught is equal to J square, and you have 4 pi epsilon naught by m E square. And according to this particular Bohr, this J is equal to what? NH cut, isn't it? And this R naught can be written as Rn because this J is quantized. And when we will put it here, then this value is equal to N square and 4 pi epsilon naught H cut square by M E square. And this is very famous. Look at, everything is constant, universal constant, isn't it? Everything is written in term of universal constant, epsilon, E, H cut. And this value is some constant, and this is very famously known as what? Bohr radius. So Rn is nothing but Bohr radius, and that value is equal to N square A naught. And if you will calculate this particular A naught, then this A naught is equal to 0.53 angstrom, and N can be 1, 2, 3, and so on. And now you can easily calculate what is value of energy. कहां से calculate कर सकते हो? कई तरीके से calculate कर सकते हो. E is equal to V effective. You can put R is equal to R naught. एक तरीका ये है. दूसरा तरीका आपको ये भी होना चाहिए. E is equal to 1 plus 2E J square upon MK square. You can put value of J is equal to what? NH cut again? Yes?
Yes, sir.
You
Yes,
can
sir.
put J is equal to NH cut, and what is value of K? E square by 4 pi epsilon naught. This is your value of K, and you will get this particular value. And what is eccentricity? Eccentricity is equal to 0,
0.
and this is for the circular orbit. So this is for circular orbit. So you can have, if you can put the value of K and value of J here, you can get the value of energy. And now, hence J is quantized, then you can write this energy is equal to, I think you will get this value. हम लोगों ने इसे calculate भी कर रखा है ना, m by 2h cut square E square 4 pi epsilon naught whole square 1 upon n square. देखो पुट करके ये आएगा 100% आएगा. जस्ट चेक इट.
Yes, sir.
है ना? मैंने क्लासिकल के ड्यूरेशन भी इसके बारे में बात की थी. नाउ यू हैव En. Your energy is quantized, and this value is equal to minus 13.6 upon n square. When you are just going to calculate this value, m is nothing but what? Mass of electron. E is charge of electron, and you know E square upon 4 pi epsilon naught. You know this value, and you can write this value, and you will get, and this is in electron volt. So this is energy for your hydrogen atom. You can also calculate the value of speed. How you can calculate the value of speed? From here, J is equal to NH cut. So what will be J? This is nothing but MVR, isn't it?
Yes,
MVR is equal to what? NH cut. So what is your value of V? NH cut upon MR, and R is here is R is nothing but RN. So V is nothing but VN, and you can put the value of RN from here. हो जाएगा ना? You can put value of Rn from here, and this value is Vn is equal to N H cut upon M. This is N square M E, and you can write something like this: M E square upon 4 pi epsilon naught H cut square. Okay, this N and this N is gone, and you have Vn is equal to M E square H cut upon, and this M is cancel out. So this is not a function of M actually, and this value is equal to 4 pi epsilon naught H cut square 1 by N. So this is your velocity in the nth orbit, and velocity is independent of mass. This is very important statement. This velocity is independent of mass and inversely proportional to N. If you will calculate this particular number, one H cut to H cut is also cancel, na?
Yes,
So
sir.
this H cut is also cancel. Okay, just cancel it. So you have Vn is equal to E square upon 4 pi epsilon naught H cut 1 upon N. And if you, and again, this is a constant. And if you will calculate, this value is, I think, 2.2 into 10 to the power 6 by N. Am I correct?
यस सर।
है ना?
Yes, sir.
2.2/6, ये सब हमने +2 में ही पढ़ा था, याद है?
Yes, sir.
मीटर पर सेकंड, ये सारे +2 में पढ़ चुके हैं हम लोग। ओके, मीटर पर सेकंड। ओके, so these are the main energy, radius and velocity, angular momentum। यही तो आप कैलकुलेट करोगे अगर कोई भी पार्टिकल अपने सर्कुलर ऑर्बिट में मूव कर रही है। यस, energy and this velocity is what? Tangential velocity. There is nothing called radial velocity. Are you getting my point?
Yes.
Okay.
Sir.
So what we have seen, let's try to analyze this data and what is actually happening to your system. एक्चुअल में क्या था, इस डेटा ये कितना कुछ रिवील कर रहा था, और फिर हम लोग नेक्स्ट आगे के एक्सपेरिमेंटल जो एविडेंसेस थे उसको हम कैसे जस्टिफाई कर सकते हैं, उसके बारे में बात करते हैं। यहां तक क्लियर है? ये एब्सोल्युटली सिंपल, इजंट इट?
Yes sir.
Yes, sir.
है ना? सो लेट्स ट्राई टू गो फॉर दिस। ओके, सो अकॉर्डिंग टू बोर, बोर ने पूरी चीजों के लिए क्या लिखा? सो ही जस्ट गिव Rn, ये सबसे ज्यादा जरूरी है निकालना, दैट वैल्यू इज इक्वल टू n स्क्वायर। बताओ वैल्यू क्या आ रही है? m स्क्वायर और 4 पाई एप्सिलॉन नॉट h कट स्क्वायर, है ना? एंड दिस इज एक्चुअली नथिंग बट n स्क्वायर इंटू a नॉट। व्हाट इज योर En? En is negative and that value is equal to m upon 2h cut square, and you have E square 4 pi epsilon naught whole square 1 upon n square, and this value is equivalent to, and this is in angstrom, okay, and this is, sorry क्या हुआ?
सर ये मिस का नीचे होगा ऊपर
4 पाई एप्सिलॉन
अच्छा सॉरी हाँ 4 पाई एप्सिलॉन नॉट ऊपर आएगा, सॉरी 4 पाई एप्सिलॉन नॉट h कट स्क्वायर ना by m स्क्वायर, sorry by m square, sorry, this is minus 13.6 upon n square, okay, and what is your vn का जरा वैल्यू बताओ क्या आ रहा है? अभी करवाया ना, बताओ।
स्क्वायर ओवर
E square h cut
4 pi epsilon naught
ई स्क्वायर बाय
E square by 4 pi
By?
epsilon naught
अच्छा e square by 4 pi epsilon naught h
h
cut
cut
1 upon n,
yes sir।
ठीक है ना? एंड दिस वैल्यू क्या हुआ पुनीत, तबियत खराब है?
हाँ सर।
क्या हो गया?
सर कुछ नहीं, सर्दी जुकाम लग गया था।
ओके, हो जाएगा ठीक, ओके गुड।
Yes, sir.
सो दिस इज Rn, En and Vn, okay, so these three thing is there now। अब यहां पर क्या हो रहा था, बोर ने किस चीज को जस्टिफाई करने की कोशिश की थी? सो व्हाट यू हैव सीन, तो यू कैन सी दैट सपोज there are different level of n, this is your n is equal to 1, this is your n is equal to 2, next is what, your n is equal to 3, है ना? And similarly, and this value is what, minus 13.6, this value is what, minus 13.6 by 2 square, कितना आएगा? minus 3.4, okay, and this value is equal to minus 13.6 by n by 3 स्क्वायर माइनस 1.5 इलेक्ट्रॉन वोल्ट, यही है ना? कुछ इसी तरह से होगा,
yes sir, yes sir।
ठीक है? एंड नाउ व्हेन द ट्रांजिशन विल टेक प्लेस फ्रॉम सम ऑर्बिट, हायर ऑर्बिट टू द लोअर ऑर्बिट, देन व्हाट विल हैपन, द रेडिएशन विल रिलीज। रेडिएशन क्या हो रहा है? वो रिलीज हो रही है, ठीक है? और बेसिकली विजुअल रेंज कहां आ रहा है? तो अगर आपको n के ऊपर जो भी ट्रांजिशन आ रहा है दैट इज नोन एज व्हाट? लेमन सीरीज. जो सेकंड के पास आ रहा है दैट इज व्हाट? बॉमर सीरीज. एंड बॉमर सीरीज इज व्हाट? इन अ विजुअल रेंज. ओके. एंड 3 पर आ रहा है दैट इज डिफरेंट लेवल ऑफ वेवलेंथ और डिफरेंट रेंज ऑफ वेवलेंथ. इस तरह से आप चीजों को देख सकते हो. नाउ ये चीजें तो ओवरऑल ठीक ठाक थी, बट व्हेन यू विल गो एंड सी द दिस, और ऑब्वियसली ये एनर्जी लेवल कैसे पता चल रहा है? ये पता चल रहा है कि आप दो लेवल के बीच की एनर्जी डिफरेंस देखो और उससे आप लैम्डा निकालो. इजंट इट?
यस सर.
है ना? उससे आप लैम्डा निकालोगे. सो व्हाट विल बी योर डेल्टा ई? डेल्टा ई इज इक्वल टू EF माइनस EI. यही होगा. एंड सपोज ऊपर से नीचे आ रहा है, सो दिस वैल्यू इज इक्वल टू व्हाट? माइनस, इसी में लिख देते हैं, माइनस M अपॉन 2H कट स्क्वायर E स्क्वायर अपॉन 4 पाई एप्सिलॉन नॉट. और ये क्या हो जाएगा? दिस वैल्यू इज 1 अपॉन NF स्क्वायर माइनस 1 अपॉन NI स्क्वायर. यहां माइनस ले लिया है तो ये NI माइनस NF हो जाएगा ना. जस्ट चेक इट. तो इसको मैं प्लस ले रहा हूं. सो दिस वैल्यू इज इक्वल टू क्या हो जाएगा ये? अगर मैं प्लस लेता हूं तो NI माइनस NF. ठीक है. NI माइनस NF अगर मैं इसे प्लस ले रहा हूं तो यस, यही होगा ना.
Yes.
And what you will do, and you will just see, and obviously this energy is equivalent to hc upon lambda, and this is the actual energy of photon or radiation which is just coming outside due to the transition of electron from here to here or here to here. क्या वेवलेंथ हो रहा है हम यहां से इसे निकाल सकते हैं. Isn't it? And this can be also written as 1 upon lambda, and this value is equal to M upon 2H cut square E square upon 4, and this square na, this is your square. Okay. E square upon 4 pi epsilon naught whole square 1 upon HC. आप इस पूरे टर्म को कैलकुलेट करोगे. दिस हैज ऑल्सो अ वेरी यूनिक वैल्यू एंड दिस इज वेरी पॉपुलरली नोन एज व्हाट? रेडबर्ग कांस्टेंट. क्या कहते हैं इसे? रेडबर्ग कांस्टेंट. जिसे हम R इंफिनिटी के थ्रू दिखाते हैं. Why R infinity? I will just tell you. And this R infinity 1 upon NI square minus 1 upon NF square. You can calculate this value of R infinity. That will be, I think, 1.09 into 10 to the power 7. है ना? And meter inverse. Okay. So this will be your R infinity. Now look at here. इससे जो भी डेटा मिल रहा था, वॉट एवर बी द डेटा कमिंग फ्रॉम दिस पर्टिकुलर रूल, जो भी लैम्डा हम मेजर कर रहे थे, उससे चीजें थोड़ी चेंज मिल रही थी, एग्जैक्ट नहीं मिल रहा था. एंड दैट इज एक्चुअली एक तरह से ये देखा जा रहा था कि दिस एनर्जी इज नॉट एग्जैक्टली दिस वन बट स्लाइटली चेंजिंग विद दिस वन. ये एनर्जी क्या हो रहा है? स्लाइटली चेंज हो रहा है. This lambda is not actually that lambda which is coming from this particular transition. So this is a very weird situation. What is there that you can explain in this particular thing? Then what will happen? Actually, जब आप हाइड्रोजन एटम की बात करते हो, जब आप हाइड्रोजन गैस की बात करते हो, then what you will have? You have not only hydrogen atom, rather there are isotopes of also hydrogen. There are क्या क्या आइसोटोप होता है हाइड्रोजन के? एक तो हाइड्रोजन है और दूसरा क्या है? ड्यूटेरियम, ट्राइटियम. ठीक है. तो दीज आर द मेन थिंग. और इसमें क्या हो रहा है? न्यूक्लियस में आपकी क्या हो रही है आपकी मास चेंज हो जा रही है ना?
यस सर.
व्हाट इज आइसोटोप? आइसोटोप क्या होता है? मास नंबर विल सेम,
atomic number same.
atomic number same, atomic mass is going to change. है ना? So atomic number same है, इसका मतलब क्या है? Proton is same and neutron is going to change, isn't it?
Yes sir.
So what will happen? Here we have taken an assumption, and that assumption is that this particle, this mass m is only mass of electron. ये mass m किसका mass है? Mass of electron का, because we have not contributed the mass of proton in our calculation. Mass of nucleus का contribution हम लोगों ने नहीं लिया. So obviously it will create a little bit problem. So next जो correction थी, जो actual lab में जो measurement आ रहा था, that measurement is corrected by the next level of correction, and that correction is what? Correction of reduced mass. किसके थ्रू का correction हो रहा है? Correction of reduced mass. So reduced mass, obviously you know what is reduced mass, and you can just go for two body particle. किसके बारे में बात कर रहे हैं? Two body particle, and two body particle के लिए reduced mass क्या होगा? We all know, हम लोगों ने classical mechanics में कर रखा है. What is this particular reduced mass?
M1 M2 upon M1 plus M2.
Very good. So this reduced mass is basically this reduce. इसी के ऊपर आपका main problem आता है. This reduced mass is equal to m of the electron, mass of the nucleus by mass of electron plus mass of nucleus. This is your mu. Now what will happen? This all formula is going to change. क्योंकि अब आपको मास को किससे रिप्लेस करना होगा?
Reduced mass से.
Reduced mass से. So let us try to go and replace this thing with the reduced mass. और इसी टर्म में हम सारा चीज लिखने की कोशिश करेंगे. Don't worry. In the same term, we are just trying to write all this thing. Okay? So let's try to go for this. देखते हैं, लिख लें इसे क्या? Rn क्या हो जाएगा? n square 4 pi epsilon naught h cut square mu e square. Are you getting my point? यही होगा ना?
Yes sir.
बट यहां पर आप क्या करते हो? आप थोड़ा सा ट्रिक प्ले कर जाते हो. क्या ट्रिक प्ले करते हो? बिकॉज हमें इस पूरे कांस्टेंट का वैल्यू पता है, and this is nothing but what? Mass of electron. This m, where m is nothing but mass of electron. So what is the trick? The trick is that you have to write reduced mass as a mass of electron. Are you getting my point?
Yes sir.
है ना? किसी भी मास को मास ऑफ इलेक्ट्रॉन में चेंज, जैसे मास ऑफ प्रोटॉन क्या हो गया? 18, 14, 40 टाइम मास ऑफ इलेक्ट्रॉन. Isn't it? So you can change this reduced mass to the mass of electron. कैसे चेंज करेंगे? हमें नीचे चाहिए ना मास ऑफ इलेक्ट्रॉन. So we will just write me ऊपर ले लिया और me क्या हो गया? नीचे आ गया. Yes? और इस पूरे चीज को आप लिख सकते हो me by mu, and this thing can be into mu, and that value is n square, and you have 4 pi epsilon naught upon me, and that is m is mass of electron into e square. Are you getting my point? अब पूरे चीज को कैसे लिख सकते हो? That whole thing is written as me by mu n square into, this is nothing but a naught, isn't it?
Yes sir.
So you can write it in term of a naught. Similarly, what will happen? Energy. And this energy is minus m upon 2h cut square. तो यहां पर m को क्या लिख दे? Mu upon 2h cut square, and this is e square upon 4 pi epsilon naught whole square 1 upon n square. बताओ reduced mass को कहां लेकर के आना है? ऊपर लेके आना है ना?
Yes sir.
तो ऊपर लेके आएंगे, then what will happen? This is mu upon me, and now you have m upon 2h cut square e square upon 4 pi epsilon naught, and this thing will be something like this: 4 pi epsilon naught 1 upon n square, and this value is equal to what? Minus mu, और इसकी वैल्यू तो पता है आपको? 13.6, and here is me by n square. Now you can use this particular thing and you can easily calculate. And what about Vn? Vn पर क्या होगा? there is not any change for Vn. Okay, so there is not any change for Vn. Okay, so this value will remain same. So this value is remain E square upon 4 pi epsilon naught, and you have 1 upon h na, 4 pi h cut na, 4 pi h cut,
Yes, sir.
4 pi epsilon h cut and 1 upon n. That will remain same, and you have 2.2 into 10 to the power 6 meter per second by n. So this is all about the correction due to reduced mass. And what is reduced mass? Reduced mass is m of electron and mass of nucleus. अब nucleus में जो भी mass है, m of electron plus mass of nucleus. The whole idea is that how you are writing mass of nucleus as a function of mass of electron. पूरा का पूरा आइडिया क्या है? यही है.
Yes, sir.
Okay. Now this is your correction term due to isotopic effect. ये किसके कारण हो रहा है? This is all about isotopic effect. This is all about isotopic effect. Now इसके बाद फिर इसको और भी फॉर्मूले को नेक्स्ट लेवल पर लेके आया गया, जिसको कि हाइड्रोजन लाइक एटम के लिए कर रहे थे. किसके लिए कर रहे थे? हाइड्रोजन लाइक एटम. व्हाट इज हाइड्रोजन लाइक एटम? हाइड्रोजन लाइक एटम in which outermost orbit has a single electron. Okay, so हाइड्रोजन तो एक मिल ही गया. दूसरा क्या हो सकता है? हीलियम, हीलियम
Yes.
प्लस,
Yes, sir.
लिथियम 2 प्लस. अब इसमें पूरा का पूरा जो खेल है वो किसके कारण है? वो पूरा का पूरा खेल जो है वो पोटेंशियल एनर्जी में चेंज होगा. Yes या no? What is your potential energy? What will be change in potential energy? The potential energy VR is equal to ये जो चेंज हो रहा है, what is this value? This VR is equal to हम क्या लिखते हैं? E square by 4 pi epsilon naught 1 by R with the negative sign. Are you getting my point?
Yes, sir.
लेकिन ये कब लिख रहे हैं? ये हम तब लिख रहे हैं जब न्यूक्लियस में आपके पास कितने प्रोटॉन है? एक ही प्रोटॉन है. Yes, and mass number is Z, and that will tell you all about the number of proton. Are you getting my point? So अगर किसी का Z mass number है तो पूरे के पूरे चीज कैसे चेंज होगी पोटेंशियल एनर्जी में?
Z square by 4 pi.
बताइए कैसे होगा? माइनस ZE, this is mass of nucleus into mass of electron by 4 pi epsilon naught R. So जहां जहां पर अब ये जो सारा E square by 4 pi epsilon naught है, E square 4 pi epsilon naught, E square 4 pi epsilon naught, E square 4 pi epsilon naught, ये किसके कारण आया है? What is the cause behind that? Potential energy. Are you getting my point?
Yes, sir.
ये सारा का सारा क्यों आया? This is due to potential energy. So what we will do? We will rewrite this expression for the hydrogen like atom. हम लोग ये पूरे के पूरे चीज को किसके लिए कर सकते हैं? हाइड्रोजन लाइक एटम. सो लेट्स गो फॉर हाइड्रोजन लाइक एटम. ठीक है, यहीं पर लिख देता हूं और मैं रिड्यूस मास के साथ ही लिख देता हूं. तो अब क्या चेंज करोगे? जेड की जगह पर क्या होगा? जेड ई इंटू जेड ई है ना. पहले आर एन लिखते हैं. लेट्स गो फॉर आर एन. व्हाट इज योर आर एन? ये टर्म लिखते हैं. दिस इज एम ई बाई म्यू एन स्क्वायर 4 पाई एप्सिलॉन नॉट एम ई स्क्वायर. इसे आप क्या लिखोगे? ई स्क्वायर को क्या लिखोगे? जस्ट टेल मी. जेड ई इंटू ई है ना. सो दिस थिंग विल बी रिटन एज जेड ई इंटू ई. यस, agreed or not?
Yes, sir.
So what will happen? Z will come outside. So this Rn is equal to me by mu into Z, and all thing will be known as what? A naught, n square A naught. Are you getting my point? देख रहे हो ये?
Yes, sir.
So Rn is proportional to 1 upon, inversely proportional to 1 upon Z. Rn is inversely proportional to mu. Clear है ये? चलो En वाले में क्या लिख दे, मैं यहां पर यूज कर दे रहा हूं, ये स्पेस यूज कर ले रहा हूं, या यही कर ले, आई कैन यूज दिस स्पेस ऑल्सो, है ना। ओके चलो यहां इसे हटाते हैं। And then what will happen for Rn? Rn के लिए Rn तो हो गया, and what about En? En के लिए बताओ क्या लिखेंगे, माइनस म्यू अपॉन
ZE into
टू
E.
एच कट स्क्वायर, यहाँ के जेड ई इंटू ई है ना, सो दैट इज जेड ई इंटू ई बाई 4 पाई एप्सिलॉन नॉट होल स्क्वायर 1 अपॉन एन स्क्वायर, यू कैन टेक जेड स्क्वायर आउटसाइड, सो यू हैव माइनस म्यू जेड स्क्वायर अपॉन you have n square, and that value is equal to what, 13.6 electron volt. So En is proportional to z square, isn't it? En is proportional to z square. And what about Vn? Is that it will dependent? Yes,
No, sir.
this will dependent. Yes,
Yes, sir. Yes, sir.
this will dependent. So what will happen? You will write z e into e upon 4 pi epsilon naught h cut by 1 upon n, and then you have this is z upon n 2.2 into 10 to the power 6 meter per second. So simple. So this is for hydrogen like atom. Hydrogen like atom. This is also for what? Hydrogen like atom. Okay. This is hydrogen like atom. So now you can see the semi-classical theory and Bohr quantization rule give up to some, try to explain up to some level of understanding of the spectral line of hydrogen atom or hydrogen like atom. It's good. But obviously technology will upgrade day by day, day by day. When you have much more, your spectrometer has much more resolution during the time, then what we have seen? We have seen that suppose the transition is from n is equal to 3 to n is equal, why I am taking always n is equal to 3 to n is equal to 2? This is my favorite transition. Why? Because this is in visible range. Okay, this is in visible
Yes, sir.
range. So what will happen when we try to see this transition line at the very microscopic level? Then this is not a one line. This is exactly a combination of different lines. So why this line will come into picture? What is the physics behind this particular line? We will try to understand in next class. First, we will go for the next class. In the next class, we will go for what? Basically, Bohr-Sommerfeld theory, where Sommerfeld have argued that the hydrogen atom is not only moving in a circular orbit. He again go for the classical method. He argued that it is not only moving in a circular orbit, rather it is also moving in elliptical orbit for different value of n. So if it is going into elliptical orbit, then obviously there are two generalized coordinates. What are these generalized coordinates? R and theta.
Yes, sir.
है ना?
Yes.
कितने generalized coordinate? R and theta. Then you have two quantization rule. One is for R and one is for theta. Yes?
Yes, sir.
Theta वाला तो सही रहेगा because angular momentum is conserved. That is the same argument taken by the Bohr. But what about R? R वाले को कैसे देखेंगे? And we will use this concept into next class. So next class we will go for Sommerfeld theory, and then we will go for a quantum mechanical technique to understand these fine lines with the help of fine structure. Okay?
Yes, sir.
So आज के लिए इतना ही रहने देता हूं. आपका काम क्या है? ये फॉर्मूले को बहुत अच्छे से दिमाग में रखो. याद करने की कुछ भी जरूरत नहीं है. आपके पास लॉजिक होना चाहिए और जस्ट प्रैक्टिस करोगे तो इसके ऊपर काम हो जाएगा. So tomorrow Mukaddar sir will do the problem based on this formula. So tomorrow you have two class. One is mine, another is Mukaddar sir. He will just go for the problem of this formula. Okay?
Yes, sir. Yes,
Okay.
sir. Thanks.
So
Thank
is
you,
that
sir.
is that okay from my side? ठीक है?
Yes, sir.